Hello, my name is Jackson Gooden, and this will be my presentation over assessment and evaluation for STEM teachers. Um, the standards that I linked will be from the topic 3 assignment, and this is going to be over secondary science. So the Oklahoma standards regarding the gravity portion of secondary science, the first concept that will be linked to the first standard, and then the second concept will be linked to the second standard. The 8-point ESS 1.2 standard says develop and use a model to describe the role of gravity and the motions within galaxies and the solar system. And then the second model is construct and present arguments using evidence to support the claim that gravitational interactions are attractive and depend on the masses of interacting objects and the distance between them. So moving on, we have our first concept. And that concept is the sun's gravity keeps planets in orbit. Planetary gravity keeps moons in orbit. So when we look at the DOK questions for 1 and 2 for this concept, DOK1 addresses the recall and reproduction um, of that concept. So the question that I have for the depth of knowledge number 1 is what force keeps the planets in orbit around the sun? Some of the misconceptions, or one of the misconceptions for this question, is that students may think that the sun's light or heat keeps the planets in orbit, and not its gravity. And the remediation that I could take to teach this better is to demonstrate that light and heat radiate outward but don't pull objects inward. So I could use a simple analogy like a magnet attracting paper clips to show that gravity is an invisible pulling force and not a pushing or heating one. Moving on to the depth of knowledge two. Depth of knowledge two covers the skills and concepts. So the question that I have here is compare the gravitational relationship between the sun and the planets with the relationship between Earth and the moon. Some of the misconceptions that students may have with this type of question is some students may think that the moon orbits the sun directly, or the Earth and the moon share the same orbit around the sun. The remediation that I could use for this question is use a diagram or model showing concentric orbits, planets around the sun and moons around their planets, and emphasize that the moon's path is influenced by both Earth and the sun, but mainly Earth's gravity keeps it in orbit. Moving on to depth of knowledge 3, this covers strategic thinking. This question is if the sun suddenly lost its gravity, what would happen to the planets and their moons? Some of the misconceptions that students may have about this question is students might think the planets would fall toward where the sun was or stop moving altogether. Some of the remediation that I could use is use a marble string model. When the string is cut, the marble moves off in a straight line, and I could reinforce that gravity provides centripetal force that curves motion, and without it, inertia keeps objects moving straight. And then finally, moving on to the depth of knowledge 4. This is the extended thinking, the highest level of the depth of knowledge question here. Um, the question that I chose was design a model or simulation to show how gravity affects orbital motion in a solar system. Explain how changing the mass of a planet or its distance from the sun would affect its orbit and the orbit of its moon. So some of the misconceptions, or one of the misconceptions that students may have regarding this question is students may think that heavier planets orbit faster because they are stronger, or that distance doesn't affect gravity. Some of the remediation tactics that I could use to help students get a better understanding of this question is have students experiment with simulations. One of the more common simulations that we use in secondary science is PhET. And so I could use the PhET gravity and orbits simulation to see how mass and distance affect orbital speed and shape. And so while I'm performing that simulation, I could also emphasize that gravity weakens with distance and that orbital speed depends on the gravitational pull. So that kind of sums up our first concept that ties to the first standard. This is going to be our second concept that we're going to talk about today. Uh, the law of universal gravitation describes how gravitational force depends on the mass and distance of objects. All right, moving into our depth of knowledge questions 1 and 2 for this concept. Like I said before, DOK1 emphasizes recall and reproduction. So the question that I chose for this concept, for this depth of knowledge level, is what two factors determine the strength of the gravitational force between two objects? Some of the misconceptions that students may have is students may think gravity only depends on one factor, usually mass, or that larger objects automatically have more gravity no matter how far apart they are. The remediation tactic that I could use for this level of question is use visuals showing two scenarios, discuss that both mass and distance matter. Uh, Greater the mass, the greater the force, but greater distance decreases the force. Moving on to DOK2, skills and concepts. The question that I chose for this one is if the distance between two objects doubles, what happens to the gravitational force between them? One of the misconceptions that students might have is students might think that doubling the distance simply halves the gravitational pull. And so what I could use for remediation is create a table where they calculate the force at 1x, 2x, or 3x distance to see the patterns um, of, of the gravitational force. I could reinforce that distance affects gravity much more strongly than most um, except the sun, but mainly Earth's gravity in orbit. Moving on to depth of knowledge 3 and 4 for this concept. DOK3 covers the strategic thinking. And the question that I chose here is compare the gravitational forces between Earth and the moon versus Earth and the sun. Why does the moon orbit the Earth even though the sun's gravitational pull on the moon is stronger? So the misconception that students may have for this question is students may think that students may think the moon should orbit the sun directly since the sun's gravity is stronger. So the remediation that I could use is use a scaled model or simulation. Um, like I said before, FET is a common one, and so we could use gravity in orbits to show that distance strongly affects local gravitational control. And I could explain the concept of dominant gravity and how proximity can outweigh the total strength over vast distances. And then finally, moving on to our DOK4 question, the extended thinking for our concept number 2. The question I chose here is design an investigation or simulation that shows how changing the mass or distance between two objects affects gravitational force. I could predict and explain how each change will, um, excuse me, predict and explain how each change will alter the gravitational pull. Some of the misconceptions that students may have with this question is students often assume changes in mass or distance affect gravity linearly. The remediation tactic that I could use for this type of question is to guide students to collect and graph data from simulations, help them visualize a curve that drops off quickly with distance. This illustrates the inverse square relationship between gravity and distance, and then encourage them to explain the pattern mathematically and verbally as well. So these are just our DOK questions for both of our concepts. We're going to move into some of the formative assessment strategies that I could use to help my students gain a better understanding of these standards. So the first strategy that I would use is exit tickets. Exit tickets are a great and efficient way to gather data. They're a quick snapshot of my students' learning where they can write them down on a piece of paper or submit them electronically. And exit tickets are great for targeting misconceptions efficiently. The second strategy that I researched was a what if discussion. So what if discussions reveal conceptual depth, and they add, uh, excuse me, they reveal conceptual depth and promote a higher order level of thinking. So we're able to reach those DOK3 and DOK4 questions, where I encourage students to use their critical thinking skills and problem solving skills in these questions a lot more than our DOK1 and 2 questions, which may just be recall. And then moving on to our third strategy here, I'm in the way. Um, the third strategy is my technological strategy that I would use. It is a digital simulation reflection. So, like I said throughout our presentation today, one of the simulations, more popular simulation softwares is PhET, and so oftentimes PhET simulations can bring abstract concepts to life, and this is a way for my students to experience inquiry-based learning, and they can also discover and use higher order level thinking to decipher what's going on in their simulation. Um, Finally, moving on, the last thing we'll cover here is how to report student progress to students and families. And so I just have a short paragraph here. I will communicate student progress regularly through formative feedback, digital updates, and scheduled conferences. My goal is to ensure students and families clearly understand what each assessment measures and what the next steps for learning are. Assessment data will be handled with honesty, confidentiality, and respect. Um, always used to support growth rather than label ability. Scores will be reported ethically, reflecting accurate, fair, and unbiased evidence of student learning. That wraps up our presentation. Thank you so much.